Good morning, good afternoon, everyone. Columbus and I are excited to discuss with you today and give you some pointers on how to get your batteries and electrical system ready for the summer heat wave. For most of us, some of us, summer's already here, but just want to make sure you don't forget that it's so equally important to ensure that the batteries, your batteries and electrical system are at peak performance during these warmer weather temperatures, just as it is for the wintertime. It's all the things that you do during the summer months that really play havoc with you that first cold snap. So we're going to go over some things you can do and prepare for the summer and make sure you have as trouble-free winter when that rolls around as possible. Some of the reasons for failure during these summer months: high temperatures increase the rate at which a battery will deteriorate, or resulting in a shorter battery life. Also, sulfation sets in. Another thing, we'll discuss this further in the webinar, is some applications are stressed more in the summer months, where they're just sitting not doing anything. So we'll kind of cover that later on. But these are some of the reasons for failure. So now, kind of going into what's taking place in these warmer temperatures with your battery. Some of the things you may not realize is going on, because typically in the summer months, kind of go on cruise control, you think, because everything's working properly, everything's working great. Not having as many jump starts because my my battery, the capacity of that battery is increased. So, but what's happening is, a term called plate shedding, or battery grid shedding. This is a reaction that cannot be avoided, but can be better managed to extend the life of that battery. And this chemical reaction increases as these temperatures increase. But basically, what's happening, as you discharge that battery, you're driving that acid into that battery. And then the reverse effect, when you charge that battery, you're driving that acid back out into the battery and electrolyte. But what happens in that chemical reaction is those plates start to deteriorate, and it happens a lot faster in the warmer temperatures. And when those plates start to shed, that material has nowhere to go. It drops down to the bottom of that battery, and it can start to build up. That's where you see the sludge build up here. And eventually could result in a shorted cell battery. You just really start to lose the efficiency and the capacity of that battery, the surface area of that battery. Another thing that takes place is sulfation. Kind of some examples here of some the picture on the left shows a not properly managed battery. When you drive that acid into the battery, as that battery becomes discharged with all the loads, you're leaving that fluid, the electrolyte, basically turns into a water solution. So you start getting sulfate crystals built up on the lead plates, which reduces the surface area and just the efficiency of the battery. On the right there, you see a properly managed battery within the lead plates. So keep in mind what's going on, what you might not think's going on during these warmer temperatures. It's so important to have a really good PM process during the summer months as it is for the winter months. So doing all this will make sure you are ready to roll once winter does come around. Again, I kind of covered this already, but why do electrical problems show up in the first cold day? Again, keeping that battery as close to 100% state of charge as possible, during those summer months is key. And a good PM process during the summer will greatly reduce those issues once winter does roll around. So now we got a poll question. What equipment can benefit from a good summer PM? If Your options are trucks, reefers, heaters, lift gates, or all of the above. I'll give you a few seconds to plug in your answer, and make sure you don't put it in the Q&A section. You can actually select it on the screen here. So go ahead and do that. Okay, everybody on key today, 100% said all of the above, so you're exactly right. It's so important, you know, whether it's trucks, reefers, heaters, lift gates, just knowing all your power demands. You know, whatever you take out of that battery, you got to put back. In the summer months, again, that chemical reaction is going to speed up. You might think you're in good shape, but you're setting yourself up for a lot of issues when winter rolls around. So I'm going to turn it over to Columbus. He's going to kind of go over some other things regarding battery charging.
I appreciate that, Jimmy. So some of the biggest issues with all equipment, no matter what season it is, no matter where they're located, is just keeping them batteries charged and making sure that they maintain that charge so they can provide power to any of those electrical systems. So when it comes down to the trucks, with more states, you know, adding in all these different idle restrictions, it's making runtime a little bit less for some of these drivers when they're in their downtime or if they're stopping at location to location. So the only charge that they're getting, or the main bulk charge they're getting, is going to be while this truck and trailer is in motion. And while it's sitting, you know, of course, you know, with warmer months, nobody wants to, you know, just sit in silence in the heat. So, of course, you can always expect those higher cab loads as well. And I guess by this, I mean, you know, you've got a lot more energy that's being taken out of those batteries to help run your AC, your fans, you know, any other things that you might use as more of a comfort or necessity in some cases to help, you know, keep those drivers, you know, in a nice, cool environment.
Exactly. Just, you know, like with electric APUs, you just look at your battery buckets. You know, how much you got to fill up, how much energy you got to replace into those batteries. You know, electric APUs. Sometimes you're dealing with 8 batteries, you know, four APU batteries, 4 hotel batteries. Again, it goes back to getting those batteries back up to 100% state of charge, or as close to it as possible.
Now, when it comes down to your lift gates, I mean, same story, you know, applies. You know, always, again, and I don't think we could say this enough, is just making sure that you are, you know, keeping those batteries charged up and maintained as best as you possibly can. You know, when it comes down to summer times, everybody's looking, you know, quick, let's get this done, go home. So oftentimes you'll see longer cycle times, but you'll also see a higher increase of using that power down option on the lift gate, which, you know, it's pretty well known, but, you know, some may overlook it from time to time, but using that power down takes out a lot more energy than using gravity down. So in the summer months, you know, gravity down is going to get you by just as well as any of them. Power down usually helps out a lot more in the winter times, especially when those hydraulic fluids don't want to flow near as smoothly. So that's where you start seeing it, you know, slow up, slow down. You know, that's when power down is, you know, comes in most handy. But when it comes down to the warmer months, it's not near as much as a demand, and it saves you a ton of energy when it comes down to, you know, draining from those batteries.
Yeah, you can nearly cut that, you know, that in half by just switching over to that gravity down. But a lot of that may have to involve some driver training, and because that, a lot of times that's an option for them to pick from. So just like Columbus said, keep it in mind that any of those little things you can do, you know, during this time is key. Again, it's all about what you're taking out. We got to put that much back in.
All right. Now, when it comes down to your reefers, unlike the wintertime, the reefers are going to be picking up and they're going to be running just about as hard as any other part on the truck itself. So, knowing where your battery location is and knowing, how well ventilated it's going to be, is it going to be able, be easily accessible to be able to check? Is it going to be clear of corrosion or debris? Always want to make sure your batteries are in good health and good looking condition. That way it just makes the whole process a little bit smoother. Now, if you notice right below that battery location, you see those increased parasitic loads. And what this is referring to is more along the lines of your GPS or any kind of telematics that you may have tied off into this battery. And though you may not think they may draw a lot, and in honesty, they may not, but over time, all those minor loads that are being put on that battery, they add up. So, it's always good to check in on those and make sure that you're getting everything under control when it comes down to your parasitic loads.
Yeah, so we had a question come in, actually, a couple of them, but one question came in is, how do you turn off the power down? It varies with, liftgate manufacturers. Some, could be on the switch, could be at the pump, but that's something you could consult with your liftgate OE and figure out where that feature is and how you can turn it off, if that's even an option. But we just want to make sure you consider that. Power down's not really necessary in the when it's warm outside, because the hydraulics are flowing a lot smoother, and that gate's going to go down just as fast, power down versus just gravity. So just consult with your liftgate OE, and they can help you out with that.
Now for the heaters, this one here is one that you're not going to see a whole lot of action out of during the summer, but don't let that just kind of lay in the back of your mind. This right here does still have a battery, so we always want to make sure that it is maintained. And since it's not going to be running, it's not going to be getting that charge that it needs. But at the same time, it's still going to have those same parasitic loads that you might find on your reefer, such as, again, your telematics or your GPS, constantly drawing down that battery. And what's going to happen is winter's going to roll around when you're going to need that. And then I don't know if you guys are a little different than I am, but I'm kind of a short feller, and I don't necessarily think that I could just jump up there and change that battery out quick, fast, in a hurry. So always make sure that you keep that in mind to check that.
It could also be a safety thing too. Having to locate a ladder or one of those roll around step ladders to it's not an easy task to get up there and change that battery. So take that into consideration.
So now that we've highlighted some of these issues, how do you ensure that you are ready for summer? And typically when it comes down to us, we follow this little simple 3-step process that's been able to hold us over pretty good. And what we always start off with is testing the batteries. So from the very beginning, from truck to trailer to reefer to heater, these batteries are going to be the heart of your electrical systems, and if they're not treated right, then neither are the trailer and them. And in the end, you could be left stranded on the side of the road, if not taken seriously. So step one is, we'll start out by testing the batteries and then making sure that your open circuit voltage is going to be somewhere around 12.4 volts or higher. By this, it's just taking a battery at rest, checking positive and negative on there. If your voltage that you're reading off your meter is going to be higher than 12.4, then you're in the clear. You can continue on with your test.
Yeah, some battery testers just will not let you proceed, and Columbus will touch on that in a little bit, but picking the right tester is key as well.
And then next, you just follow up with just making sure that you're isolating these batteries and testing them individually. And the easiest way, of course, is just start removing everything. Make these batteries, just side by side, and that way you can test them each individually. Don't try to break your back, ripping everything out of these battery boxes or out from underneath the truck, but try to make it to where you can test them all and get the best results. And this is one that I've seen far too often in the field, is taking care of these lead pads on these batteries. Oftentimes you'll check and you've got either dielectric grease that's all over them, you've got corrosion buildup, some of them are cracked due to over tightening. So just making sure that everything is intact, making sure that it's clean, making sure that when you go to put on your tester or any kind of adapter, lead adapters, metal, plastic, hopefully not, but making sure that it's getting that good contact that it's going to need.
Yeah, a lot of these steps we're going over, and just with my experience, they tend to get missed, but it's so important that you don't miss any of these steps. That lead pad, that is your electrical connection. It's so important to clean it. So these are the tips and tricks we're trying to help you guys put together so that you're ready for summer and winter.
And then kind of like how I was saying there towards the end is install those lead adapters. If you're wanting to get the best contact that you can get, just shy of, welding it on there, then go ahead and just install these when you do your tests. And I think that you'll find that when you hook up your tester to it and you get some better connection and better grip, and then you're going to see more accurate results. And then finally, what you want to do is you just want to make sure that you're using a good tester. I'm not saying go out there and buy the most expensive one, but find the one that works best for you, that's going to get the job done right, versus having to come back and do test after test after test and then get miscellaneous results that are never going to balance out. And when it's all said and done, you want to keep the good batteries and replace the defective ones. But when you say that, what are you going to do? You're going to throw in just some random battery? No. So what you want to do is you want to make sure that you're replacing, the batteries that are found to be defective with batteries that are of the same brand, make, and model. Something that probably has the same cranking amps if it's going to be in the truck, or same reserve capacity if it's going to be in the lift gate. But you just want to make sure that you're not putting, mixing flooded or with AGMs or vice versa. And then you just, also you want to make sure that you're keeping them within the same general date range. So if you've got one that's from June, you want to make sure that you're replacing it with something around about that same time frame, give or take 3 or 4 months.
Yeah, so we just had a question come in, and probably a good spot. Hopefully I don't think it's covered later, but Columbus touched on it a little bit. What about proper battery selection, AGM versus flooded cell per the application? Yeah, great question. You got to know the application. For a liftgate application, bigger is not better. You don't really want that high CCA cranking battery for a liftgate application, a cycling application. You're looking for that reserve capacity, that 750 range, but really pay close attention to that reserve capacity. AGM, they do cost more, but you kind of get the best of both worlds on an AGM. You get that cycling, that higher CCA along with the reserve capacity. So it is important to, we'll talk about speccing equipment later, but it is important to really consider what battery you're using. So we had another question come in. After we clean the batteries and reconnect, we use battery protector, red spray. Would you recommend this or not? Absolutely. Again, corrosion, we'll talk about that a little later, but making sure you're protecting all those connection points, cleaning those connection points, all that builds up resistance in the circuit and is going to cause voltage loss. So when you get into charging those batteries and or even cranking, if you can't get that power from point A to point B, it's going to cause you issues. So one of the things I tend to see a lot is, technicians are told to use that protection spray, but they never clean the connections beforehand. They just spray it over it, all the corrosion, and just kind of encapsulate all that in. So you got to clean the connections first before you use that spray. So hopefully that answered your question on battery selection and battery spray.
Super. Now I'm going to turn it back over to Jimmy here. He's going to tell you a little bit about testing the cranking systems on to the batteries.
All right, so using a battery tester or a system analyzer and looking at the cranking circuit, this picture illustrates a single cable using the chassis as a ground, but first thing you want to do is you got to test your cables. You got to make sure you can get that power from the batteries and deliver it to the starter. And using RP 129, which is in the resources section as well, you're allowed a half a volt drop at 500 amps. So that's a half a volt between that positive leg of the circuit and the negative leg of that circuit. So some things that could cause that to fail would be, like I just mentioned, corrosion. Corrosion buildup on the terminals. It could be undersized cable as well. Real easy fix. You could, start cleaning those connections up, reconnect everything, test it again, see if you pass. But you gotta start with the main cables first. Make sure you can deliver that power. Next would be testing the charging circuit. Again, same here. On the charging circuit, it typically uses the starter as a junction point. But again, you got to make sure you can deliver that power from the alternator through the cables and to that battery to keep it properly charged. Again, going back to RP 129, you're allowed a half a volt drop at the alternator's rated output. So again, you got to make sure your connections are clean and you can deliver that power from the alternator to the batteries. Then you can test the output of the alternator. Whatever alternator you spec'd on that vehicle, make sure it's performing. Make sure it's outputting it where it's supposed to be. Make sure it's the voltage is regulating. All this combined will determine, if you're able to charge with the equipment you have, if you're able to charge those batteries back up. Okay, so we have another poll question. What is the spec for TMC RP129 for the cranking cables? Half a volt while cranking, 0.25 volt per cable at 500 amps, half a volt total at 500 amps, or 1 volt at 500 amps. And I'll give you a few seconds to answer. Okay, 83% said half a volt drop or half a volt total at the 500 amps. That is correct. It's not while cranking. You're allowed a half a volt drop, again, in the total, so that's half a volt between the positive legs, the positive cable, and the negative leg of that circuit. Those combined should not exceed the half volt drop. If it does, then you need to look at cleaning connections, up your cable size, that sort of thing. So if you follow all those steps, that 1, 2, 3 step process, you're ready for the summer months, for those warmer temperatures. Again, it's all about knowing your application, knowing that power demand, and making sure you spec all the right stuff to put all that energy back into those batteries. So when winter does roll around, or that first cold snap, you're not surprised by a lot of jump starts or just depleted batteries. So I'm gonna let Columbus kind of go over what else you can do to ensure a trouble-free summer.
All right, appreciate that, Jimmy. So looking here, you'll notice that you've got some different things to check into. But we're going to pretty much start by reviewing your current specs, for new equipment and replacement equipment on existing units, or if you're looking to purchase in the future, just to kind of help better prepare yourself for the upcoming seasons. So kind of going back to a poll question that we had earlier, flooded cell or AGM, and honestly, again, you got to know your application. Of course, like Jimmy was saying, the AGM is going to run you a little bit more, but you are kind of getting the best of both worlds, and that goes for both the truck and the liftgate, as well as reefers and heaters. Also, you want to make sure that you've got the correct cranking amps. If you're jumping off into, trying to fit a truck full of batteries, you want them all to be the same. You want to make sure that they're going to be able to withstand what the truck is going to demand. And then kind of bouncing back and forth all over this, between truck and trailer, focusing on the liftgate now, but the correct reserve capacity. If you're running a liftgate off of, just some batteries that you just found laying out back behind the shop, chances are they're not going to be, taking you 120, 130,000 miles down the road. So what you want to do is you want to make sure that when you're looking for a good reserve capacity battery for your lift gates, that you're kind of focusing more somewhere around the 185 range to 220. That seems to be a pretty common for a good high reserve capacity battery. And also for warranties, is the batteries that you're currently buying, do they come with a warranty? Again, I know that can cost a little bit extra, but at the same time, when it comes down to replacing one battery, it's not so bad. But when you're replacing multiples, anywhere from 2 to 4 and beyond, that price starts to kind of add up. So warranty is always pretty handy to have.
And you just want to look at your battery provider and just make sure they do have a good program and they take care of you. Just another consideration on your batteries and just your electrical system altogether.
All right. And now I'm kind of bouncing under the hood a little bit and looking at your starters here. You see gear reduction. All right. So I know a lot of people are kind of switching from that direct drive over to a gear reduction. Get my words right. I can make this make this work a little bit better. But kind of going away from the direct drive and switching over to gear reduction. And though gear reduction again may cost a little bit more, but at the same time you're looking at a 4-to-1 ratio, and you're also getting better efficiency, so it's going to be less demanding from those batteries. And then as far as your kilowatt rating on them, you're looking higher is not always the best, but it is good. I mean, it's better, but inevitably the gear reduction is going to pretty much be the main decider on how much power is being put out. All right. Now, when it comes down to your alternators, choosing a brush or a brushless design, I guess it seems like always the latter that's always going to be the better of the two, but because brushless is going to cost you a little bit more. Not to say that neither are good, but you're going to see less wear when you choose a brushless. You're also going to get a little bit more output from that. And then choosing your correct amperage output when it comes down to choosing an alternator. You don't want to run a 60 amp alternator off in a truck that's trying to feed 8 batteries. So be considerate when choosing or upgrading your alternators. Now, as far as a remote sense option goes, you kind of want to just, if you do get an alternator that is fitted with one, you always want to take that into consideration. It's kind of like a shortcut between the batteries and the alternators versus going through any additional cables. Kind of lets the alternator know exactly where the battery stands. That way it can kind of help to counterbalance and kind of get those batteries where they need to be.
Yeah, it gives a true voltage of what it is right at the battery, so you compensate for any loss in voltage in the cables versus sensing the voltage right at the alternator. So again, kind of going back to the correct amperage output, you got to size it appropriately to what the demands are. And oftentimes that's not taken into consideration. So you really want to know what your power demands are to size your alternator appropriately, or whatever your charging system is.
And now when we're looking at inverters, these are pretty common options when it comes down to making life just a little bit easier on the road. But again, you also want to make sure that you're understanding what kind of wattage that your drivers are going to be needing when trying to spec an inverter for the truck. Are they going to be running a microwave, a fridge, running their laptops, or are they trying to have a party in there? So you need to size your inverters appropriately as well. And also thinking about a modified or pure sine. It's always kind of looked again, as pure sine is going to be just a little bit more, but it's also going to be a more pure energy. It's going to be something that's going to be pretty hand to hand when it comes down to matching what devices you can run with an inverter, and this seems to be working just about as well with anything.
Yeah, some equipment, like Columbus said, some equipment require a pure sine. Some medical equipment. You even have some pallet jacks. If you have a system for keeping pallet jacks charged, it needs that good clean power. So yeah, if you have inverters in your fleet or looking at specing inverters, you take that into consideration as well.
And then you always want to be kind of looking towards, does the inverter that you currently have or that you're looking to get, does it come with any kind of LVD or low voltage disconnect functions? This meaning that there is a designated set point to which that inverter will no longer operate after the truck is shut off. So for instance, if you have one that's set up at a 12.2 volt LVD, then once that inverter senses that the truck batteries are hitting that point, then it's going to shut itself down to help kind of preserve those truck batteries and make sure that you're able to start up the next day and get going.
We did have a question roll in regarding inverters, and a really good place to stop and talk about it. But is there a correct inverter for use with the Cpap machine? Yes, there are some that you can use a modified sine wave with, but most Cpap machines require the need for a pure sine inverter, that good clean power with no interruptions. So if it were me, and being that it's medical, I would much rather use a pure sine inverter when it comes to using a Cpap machine, just to get that good, clean, uninterrupted power to make sure that driver stays healthy and can sleep throughout the night. If that machine goes off, first thing they're going to do is wake up. So if it were me, I would use a pure sine inverter for that setup. So some other things you could use or think about, shore power. Some of the inverters that are out there, we offer some inverters as well, but they have built-in battery chargers. So anytime, it's all about opportunity charging. So if you have the ability to plug in at a 110 outlet and charge those batteries, take advantage of it. A lot of that involves driver training on just educating them on how important it is to keep those batteries charged. But shore power is a really good way to do that. If shore power, a lot of times shore power is not available, solar, that's a really good option. You're using temporary use for a panel for applications where the trucks are just sitting for long periods of time. A temporary solar panel, throw it up in the dash or anywhere for that matter, to kind of take care of those parasitic loads. Nothing ever totally shuts off. So again, when you discharge that battery, that chemical reaction happens a lot faster in the summertime. So keeping that battery, using all means to keep that battery up and charged, do so. It's really going to help. And this is one way to do that. Look at a permanent solution. This shows, permanent panel mounted on a sleeper truck. If you just want to set it up there and forget about it and just keep those batteries charged, whether you're just counteracting parasitic loads or really trying to put a good charge into those batteries, a permanent solution is something to consider as well. Permanent install on a trailer. Reefers to take care of that reefer battery. We touched on that earlier. A lot of the parasitic loads of the GPS, the telematics, or just the electronics on the reefer itself. Do something to counteract those loads and keep that battery charged. Same with the heater. We went over that. It sits in the summertime, not getting charged. So do something about keeping that battery charged. Solar is a really good way to do that. Lift gates, another good application. You can install these on top of the trailer and just constantly, not constantly, but during the daytime hours, take advantage of that solar energy and put something back into those liftgate batteries. Depending on how your fleet operates, it may require a combination of a solar and another liftgate charging system, but it all goes back to how much you're taking out. You got to put that much back in. But solar is a really good option to take care of some of these things, or at least help. So we have another poll question. Which of the following is not one of the benefits a fleet could see from using solar? Reduce idle time, improved fuel economy, improved electrical system component life, or improved tire life? I'll give you a few seconds to answer. Imagine that, 100% improved tire life. Yeah. So yeah, we can, obviously improved tire life is the obvious answer for that one. But yeah, we can reduce idle time, reduce that, the amount of time that engine has to run to keep things charged. Solar is a good way to help with that. Fuel economy, when that engine's running, obviously you're using fuel, so and just improving the overall efficiency of the electrical components. A lot of these components, most components don't like to work or don't work well under low voltage. They tend to fail pretty quickly. So this is a good way to help with that. So again, that's pretty much it. If you follow all these simple instructions and tips and tricks, and you should be ready for summer. But again, make sure you know what you're working with first. make sure you know what your power demands are, and do some things, or at least be aware of some things that you can do to help out. And again, it's really gonna help you out when that first cold snap comes around, because a lot of times people want to blame it on the cold temperatures, and the reason for all the jump starts and the battery failing on that first cold snap, it's everything that you've done to that battery or that system during the warmer temperatures of the summer months. That's the real culprit. So I hope this was helpful. Please, send in questions in the QA section, or we'd be happy to circle back and answer any. I'm looking now to see if there is any more. I think we've pretty much answered anything that's been asked so far. But we'll give you a few seconds here to post any questions. Don't forget, at the end of this webinar, there's a brief survey, so stick around to answer the survey questions. If you have any suggestions for future webinars, we'd be happy to take those suggestions and look at doing something in the future on that. So yeah, we'll give you a few minutes here to post some questions. And we thank you for joining us today.
Absolutely.
Okay, don't see any questions coming in. I think we're good to wrap this up. Again, stick around for the survey.